You can cut it with a handsaw. Drop it in water and it floats. It weighs about a fifth of a standard cinder block. You can lift one with one hand. A child can carry it across a job site. It does not burn. In standardized fire testing, a wall built from it holds for up to 4 hours at 2000 degrees without structural failure. It does not melt, does not combust, does not feed the fire, and it survives tornadoes, not shelter from tornadoes, not reduced damage, survival. Direct impact, EF4 wind speed survival, with the walls still standing after the event, while the foundation slabs of neighboring homes sit bare in the sun. There is a structure in central Texas that has been struck by 3 separate tornadoes, including a direct EF4 hit. The roofline was intact. The neighbors had slabs. FEMA examined the structure and awarded it their highest storm shelter classification, P-361, the federal government's own ceiling for what a building is allowed to claim about surviving violent wind. The material is called autoclaved aerated concrete, AAC, and right now in Oklahoma and in Kansas, in Missouri and Arkansas, in every state where tornado season runs from April through June, hundreds of thousands of homes are being built from wood, framed and sheathed and sided in a material rated for winds below what an average EF3 tornado produces on its weakest edge. Every tornado season, tens of billions of dollars in damage. Entire neighborhoods reduced to slabs. The walls weren't strong enough. They were never designed to be. This material was. So the question isn't why it doesn't work. The question is who benefits from making sure you never hear about it. If you want to understand why the safest wall system available to American homeowners is also the rarest, subscribe now and stay with us. This channel exists for exactly this. The first thing most people assume is that AAC must be illegal, or experimental, or prohibitively expensive. None of those are true. AAC is legal in all 50 states. There is no federal ban, no state prohibition, no safety warning from any engineering body in the world. In Germany, it accounts for a significant share of new residential construction. In Poland, in Sweden, across Northern Europe, it has been the standard for decades. It is used in tens of millions of homes on this planet. It is not expensive. At scale, the material cost of AAC competes with premium wood frame construction. The blocks are larger, installation is faster, and the thermal performance is dramatically better, which means lower energy bills for the life of the structure. It is not unproven. A century of engineering data backs it. Post-storm surveys after major tornado events have consistently found that reinforced concrete and masonry structures outperform wood frame by a substantial margin. The science is not in dispute, so if it is legal, affordable at scale, proven in the field, and used by most of the developed world, why does almost no one in Tornado Alley build with it? It is not banned. It is excluded from the easy path. Those are not the same thing. To understand how that works, you have to go back to Sweden in 1923. Europe after the First World War had a housing crisis. A team at the Royal Institute of Technology, an architect and a chemist, developed a process that would become one of the more important construction discoveries of the 20th century. The insight was counterintuitive. Instead of making concrete denser, they made it lighter. Aluminum powder introduced into the cement mixture triggered a chemical reaction that released hydrogen gas, creating millions of microscopic air bubbles throughout the material. The result, after autoclaving at high pressure and temperature, was a block that was mostly air but retained structural integrity. It floated, it could be cut with a handsaw, and it held up walls. AAC spread across Northern Europe over the following decades. By the late 20th century, it was standard residential construction in Germany, Scandinavia, and Poland. It arrived in the United States with the characteristics intact and the market reception cold. There are 2 large-scale AAC manufacturers in the United States today. 2. Here is how the material actually works. And here is the one thing the advocates will not always tell you. An AAC wall resists tornado damage through mass and continuity. At EF4 and EF5 intensities, the primary failure mechanism is differential pressure, a sudden, violent drop in atmospheric pressure that can cause walls and roofs to fail outward or implode. A wood frame wall relies on connections, nails, fasteners, sheathing panels, all discrete failure points under extreme pressure. An AAC wall is a monolithic mass. The air cells distribute impact across the entire system, rather than concentrating stress at individual joints. It does not snap at a fastener. It does not rack. It transfers load. Now here is what the engineers will tell you, and they are right. AAC walls survive EF5 winds, the roof does not. A conventional wood truss roof attached to an AAC wall will fail in the same event that leaves the walls standing. Roof failure in a tornado is the leading cause of complete structural loss. Once the roof lifts, the walls lose lateral support and the structure collapses. A complete tornado-resistant solution requires either a reinforced concrete roof deck, a concrete bond beam at the top of the wall, or a purpose-built interior safe room for the occupants. AAC walls are a massive improvement over wood frame. They are not by themselves a complete answer. Anyone selling it as a complete answer is overselling it. The honest version is, the walls survive, then you solve the roof. So why isn't everyone in Tornado Alley at least building the walls from this material? This is where the story stops being about concrete and starts being about money. The International Residential Code, the IRC, determines what materials a builder can use without a full custom engineering review. Follow the code, your project is approved. Step outside it and you pay for engineers' testing reports and evaluation documents that can take years and tens of thousands of dollars. IRC Section R301 sets wind design speeds for residential construction. For most of Tornado Alley, those speeds sit below the floor of what an average EF3 tornado produces at its weakest edge. The code was written for a wind event that a mid-range tornado exceeds as a baseline. AAC has no prescriptive pathway equivalent to what wood frame enjoys. Wood frame is the default, specified, detailed, fully integrated. A builder who wants AAC must commission a site-specific engineered design, adding cost, time, and contractor reluctance that kills most projects before they start. The organization most responsible for that asymmetry is the American Wood Council, the policy and advocacy arm of the structural wood products industry. It maintains a large code advocacy operation dedicated to the ICC cycle that updates the model code every 3 years. The wood industry has been at that table for decades. The result is a code that treats wood as the default and everything else as the exception that must justify its own existence. The AWC does not need to lobby against AAC, it just needs to make sure the code never makes AAC easy. It has been very good at that. The system isn't broken. It's working exactly as designed. If that makes you want to keep watching, subscribe and help us keep making this. Every video we publish costs the industry nothing. Every subscriber makes it a little harder to ignore. Now let us talk about what that asymmetry looks like when the tornado actually hits. There is a monolithic dome in central Texas, a structure built on the same principle as AAC, using reinforced concrete in a continuous curved shell, the same philosophy of mass and monolithic continuity, owned by a man named David South. That structure has been struck by 3 separate tornadoes. It took a direct EF4 hit in 2008. The dome stood, the roof line was intact, the neighboring lots were bare slabs. FEMA P-361, maximum classification. The federal government's own engineers looked at what happened and gave it the highest rating they issue. After the storm, the financing system had no category for what David South had built. Appraisers found no comparable sales, which is how residential appraisal works. No comps means no appraised value. No appraised value means no conforming mortgage. A structure that just survived an EF4 tornado with the federal stamp of approval was treated as an anomaly the financial system could not price. The house was still standing. Everything around it was gone, and the bank still wasn't sure it could lend on it. That friction, mortgage, insurance, appraisal is not a separate story from the code story. It is the same story. Banks lend on what the code approves as standard. Insurers rate what banks finance in volume. Appraisers compare what insurers rate. The loop is closed. Wood is cheap and has a lobby. The lobby staffs the code committees. The code lists wood as the default. Everything else needs an engineer's stamp, lab testing, and a years-long evaluation process. Banks have no comparable sales, so they will not lend. Insurers have no actuarial model, so they will not discount it. Builders will not build what banks will not finance. So the safest wall on the street becomes the one almost no one is allowed to build. Then the next tornado season starts. Here is what you can do right now. AAC is most actively used in Florida, where Polk's hurricane code reform created some of the most progressive structural requirements in the country and in parts of Texas and the Southwest. If you are in Tornado Alley, you are not helpless. Start small. An AAC garage, a safe room built into the foundation, or an AAC interior core in a new build are all entry points with less friction than a full AAC house. Ask a contractor directly. Do you have experience with AAC or engineered concrete masonry? If not, ask them to connect you with a structural engineer who has done IRC variance work in your state. They exist. Ask your insurance carrier a direct question. Does AAC or reinforced masonry reduce my wind or hail loss cost? In some markets it does. Carriers will not volunteer that information. Drop the word tornado in the comments right now. I will send you a breakdown of AAC contractors and structural engineers active in Tornado Alley, plus the state-by-state map of where the IRC variance pathway is most navigable. Tornado in the comments. Every spring, Tornado Alley watches another neighborhood disappear. The meteorologists show up. The governors tour the damage. The news cycle moves on. Next April, the same wood frame houses go back up on the same lots, under the same code, engineered for the same wind speeds the tornado exceeded before it reached the city limits. We do not have a tornado problem. We have a building code problem. The tornado is a weather event. The response to it is a political choice, made in rooms where the wood industry has a seat and the homeowners of Oklahoma do not. The IRC is not a neutral technical document. It is the output of a negotiation, and one side of that negotiation builds in wood. If you want to see what else that negotiation has decided for you, this channel is going to keep pulling on that thread. Subscribe and stay with us. There is more coming, and most of it is going to make you angry for the same reason this did. Not because the truth is hidden, but because it has been sitting in plain sight the entire time, waiting for someone to say it out loud. We don't lack the materials to survive these storms. We lack the codes that require them.